Hi there. Welcome to part 7 of the WLAN Security Mega Primer. So, this one is aptly called, as you would see in a couple of minutes, Laughing Off Mac Filters. Right? Interesting title. Okay, so let's try and understand first the origin of Mac filters. Now, Mac filters actually came from the wireless world. And basically, these were, if you look at the typical usage scenario, are used with network switches and other filtering devices like firewalls. Now, one interesting feature which Cisco has, for example, in its network switches is port security. Now, port security has a sub feature which actually allows you to whitelist a MAC on a particular port, and only those whitelisted MAC or MAC addresses will be allowed to send traffic through the port. Now, the whole idea was pretty decent, but one of the most important things is that MAC addresses, as hopefully all of you know, can very easily be spoofed. This is very true for the wired world, and the wireless world also is no exception. Now, the whole thing is that if you kind of think about the whole problem, then actually MAC addresses, if you kind of talk about the wire world where there are very few computers, also physical access to the network is almost impossible. To some extent, well, MAC address filters are reasonably safe. Of course, you cannot ward off the insider attack and other things, but at least it can be used to some level of decency. In the wireless world, it's almost laughable, and we'll just get to know why. First, to begin with, the MAC filters are not part of the .11 standard at all, right? They do not, the .11 standard does not talk about any MAC filters. So this feature is entirely a network layer filter which is actually added on the access point itself. So it is the manufacturer's option whether to add this or not. Now, as we already discussed, it's a simple way to whitelist Macs. Now, this is the part where we all laugh. And the reason is, as you saw in all the previous videos, the MAC addresses are actually part of the MAC header, which is sent out into the air in plain text. What this actually means is any attacker in the vicinity who is able to sniff packets from and to the access point can actually figure out all the legitimate clients and their MAC addresses who are connecting to that access point. And he could very easily just take one of those MAC addresses, either wait for the legitimate client to kind of log off the system, or he could just impersonate that MAC immediately, right? So let's try and look at a full demo of this concept. So the first thing actually to be done is to enable MAC filters, right? So all your access points would have different interfaces, and one on mine, I just need to go to login, I guess, it's timed out, the advanced section, and from there network filter, and all I have to do is actually turn on MAC filtering, which currently I have turned on by default. So there are currently two MAC addresses, as you can see, one of which belongs to my phone and the other which belongs to my machine. So now what we will do is, let's go to the backtrack instance and understand this problem a little bit more better. So the MAC address filter has been added. Now let's actually use AeroDump to first figure out what all we see on the air. So we immediately see our access point security tube, right, which has this MAC address. Let's also open up Wireshark. And what we'll do is, what we are interested in basically is this access point. So this access point security tube is on channel 1. So let's set the card on channel 1. And right? Now let's go back to Wireshark and start sniffing. So we see a lot of packets. Let's just stop this for a second. And let's try and find one packet destined to or from the security tube network. Here we are. So let's quickly apply a filter for the BSSID, right? And let's also remove all the beacon frames. And instead of the BSSID, well, we can just make it the address, because what we want is every packet which is going to or coming from this access point and other corner cases. Now let's go back to our prompt here, and here is what we actually want to do. We want to connect to the access point security tube, right? So what we will do is, let's use Air Replay, and Air Replay actually has this option called fake authentication. What this does is it will connect to the access point and do a fake auth and a fake association. So the case in which there are no MAC filters, this should just work perfectly, right? So let's actually go ahead and for a brief second, let's just actually disable the MAC filter. On our access point, right? So MAC filters have been turned off. Let's go back here and let's just use Air Replay to spoof an authentication, right? So here are the options: Air Replay -- fake auth. Then we have to give the delay, which is the amount of time to wait before subsequently authenticating again. That be 10 seconds. And if we kind of scroll up, here are the options for fake auth. I guess what we are only worried about is the ESSID, which is security tube. And the monitor mode interface through which the packets need to be sent, right? Perfect. So if you notice, we ran the command and it says found BSSID, and it is going ahead and authenticating and associating from time to time, right? So let's kill this, and what we'll do is let's go back here to the MAC filter part and enable MAC filters, right? Let's enable MAC filtering. Awesome, enabled now. Let's go back to our backtrack instance. And now let's do the fake authentication and association once again. So if you notice, right now, actually there are a lot of errors happening. It actually says AP rejects the source MAC address. Now, even though Air Replay is giving you all of this information, it is very important to understand what is really happening behind the scene, right? So let's start sniffing. And let's go back here and try once again to authenticate and associate. It failed. Let's go to Wireshark and look at what really happened. So if you notice, we are able to see our alpha card because now we are using the card on the hacker machine, which is our favorite little alpha. And the alpha card has sent an authentication request, right? So if you kind of look at the packet, here is the authentication request, and here is the response from the access point, and it actually goes ahead and says, well, you know what, authentication failed, right? And post that, basically what typically happens is the alpha card is again trying to initiate a connection. So we'll go to the open authentication and what that is in the next video series. But very simply put, in OpenAuth, there are just two packets. One is the request for authentication packet, and the other is just the response from the access point saying, well, you know what, succeeded. But in this case, we are miserably failing. Request goes through, but the access point actually goes ahead and denies access because MAC failure has happened. So how do we solve this problem? Now there are multiple techniques to do it. The first one actually is very simply to observe the air and wait for a wireless client to connect to the access point. Note down the MAC address of that client which is successful in connecting to the access point and simply use that MAC address. That's all there is to it. If you do not find any client, you could send a broadcast deauth so that any client which is probably in power save mode or any mode may immediately like connect back and you start seeing a lot of traffic. So let's do the following. My phone's MAC address is configured. So I'm now connecting with my phone. But before that, to know the MAC address of my phone, let me just use AeroDump. Let me actually give it a channel 1, Mon 0, that we are only on channel 1. And now if you notice, I'm connected to the security tube network. Right? And very clearly, security tube has the BSS ID ending in 8025, and right now here we are. So this is the MAC address of my phone. If you notice, I'm able to see another client also connecting. The funny thing is this is just an unknown client. So I guess one of my neighbors may have connected to this access point hoping for free internet access. Well, unfortunately, I think he's landed up in the worst access point possible. I may just fire Metasploit right now. Kidding. So now that we have the MAC address of the client, we're going to put it to good use. And what we can actually do is, there is one option, if you kind of scroll up and check, where we can actually mention the source MAC address, right? So what happens is AirReplay will now spoof the source MAC address of the alpha card with this new MAC address. So let me actually give it the -H option, paste the MAC address of my iPhone, and now let me start another authentication association attempt. Awesome. If you notice now, given that we have modified our MAC address on the Mon0 interface, now if you notice, our authentication and association both are successful. So let me quickly sniff over the air so that we can just quickly verify this entire thing once again. So a lot of packets going through. If I kind of stop this and quickly check what happened here, if you notice, an authentication request went through, right? And basically from the client, and right now instead of the alpha card, we actually see an Apple based client. This is because we have spoofed our MAC address, and this is the response from the access point saying successful, having the status code 0. In the last case, we had status code 1, which was an unspecified failure. After that, we have the association request and all of that going through. And after association request, if you kind of scroll down, you would see the association response from the access point. Now, if you're wondering what are these additional packets, actually all of these are the same packet. If you look at the sequence number, it says 2019 for many of these packets, and similar trends are there up and down. These are retransmissions over the air, right? So retransmissions, if you notice, typically happen when probably the client which has sent the frame has not yet received an acknowledgement, and it just wants to very quickly figure out and just send across another frame to ensure that the receiver is receiving it. Okay, so very simple. And let's now kind of quickly go down below, and what you would notice is that Now we are successful in authenticating and associating with the spoofed MAC address, right? Awesome. So let's go back to our slides. So this is why we aptly named this chapter Laughing Off MAC Filters, because the whole funny thing is, well, the whole idea of the MAC address being some sort of a shared secret is of course that it's going to be hidden, right? That only the client and the access point is going to know about it. In this case, for wireless, this is absolute stupidity, because the MAC address is actually broadcasted over the air for anyone to see in the RF range. And hence wireless MAC addresses, MAC filters are a useless protection schema. Now here's the funny thing: when you go to airports and other places and hotspots, they have these kind of sign in and probably use the hotspot kind of a facility, where at one time and even now in many cases they have something called captive portals. And captive portals, once they authenticate you over the web page, essentially use MAC filters to ensure that only the authenticated access points are getting authenticated clients are getting on the wireless network. And I mean, given that you can practically use anybody's MAC, I mean, all of these hotspots and airport networks are practically vulnerable to very simple MAC spoofing and usage of the network. Anyway, that's all for this video. Hope you've enjoyed it. Any questions, please leave them behind in the comments. I'm very happy to see a lot of you are actually trying and working along with the videos. Ask your questions. I'll try my very best to answer them. And that's it. So in the next video, we'll look at hacking WLAN authentication, right? Okay, see you. Bye-bye. Enjoy.